where it's shifting to, if it's opening up, if it's opening down. But we've never actually even talked about what the actual definition of a parabola is. So let's talk about that. So by definition, a parabola is the set of all points in a plane that are the same distance from a given point Does anybody else need graph paper? No, we all got it? Oh, Stephen, you need? Yeah. Nobody else needs graph paper? We're good? Okay. So from a given point called the focus, and a given line called the directrix. Okay, let's say I said this is A, this is C, this is B. And I have a point A, C and a half. Oops, sorry, A's in the wrong spot. Let's fix that. Because I don't want it to be so small. Actually, I'm gonna move this over. So just draw this and I'm going to explain. Okay, what does this definition say now that we've gotten our diagram? What the definition says is in a parabola, every single point on the parabola will be an equal distance to the focus as it is to the directrix. What does that mean? That means if I have this green point here and you look at it, it's 1 unit to the focus and then 1 unit to the directrix. And that's not a coincidence. That is what a parabola is. Every single point on a parabola will be the same distance from that point to directrix as it is to the focus. So if you notice, this vertex point ends up being half a unit to the focus, and isn't that half a unit to the directrix? And that's basically the definition of what a parabola is. All right, there's more parts. So now we just introduced a special point called the focus, a special line called the directrix. More definitions. Next one is the latus rectum. You guys could get your giggles out. So here in the latus rectum, it's a line segment through the focus perpendicular to the axis of symmetry. And I believed we talked about the axis of symmetry last class, right? When in the video that you watched. So let's go back to the diagram after you guys finish writing this. Go back to the diagram above. Oh, sorry, let's put a little star here and we're going to say the endpoints of the latus rectum will be on the parabola. Okay, so the latus rectum is a line through the focus perpendicular to the axis of symmetry. So if we're going back to this diagram, who remembered from the last lesson, where is the axis of symmetry through? You got it. So doesn't it go right through the vertex or turning point? And it's a vertical line, so it's x equals, let's change this color here. X equals the x coordinate of the vertex. And what happens with the axis of symmetry? It creates mirror images on either side. So now what the latus rectum is a latus rectum, go back, let me highlight my focus. Here's the focus again. So is a line segment through the focus that's perpendicular to the axis of symmetry. So if the axis of symmetry is a vertical line, the latus rectum, in order to be perpendicular to it, has to be what kind of line, Lucas? A horizontal line. So what we're going to do is we are going to draw our horizontal line through the focus. But remember, I put that little star there, and what did I say? The endpoints of the latus rectum have to be on the parabola. So it looks like this, and it is perpendicular to the axis of symmetry. In the video, did I talk about the inverse parabola, the sideway parabola, or did I only talk about a normal parabola? I talked about both? Great. Okay, so let's just recap that. Equations of parabolas. So if we have y equals a times the quantity of x minus h squared plus k, which kind of parabola is this? Is this a vertical parabola or a sideways parabola? A vertical. This is our normal parabola. And we know that if a is greater than 0, we're going up. If a is less than 0, we're going down. We also know that it will have a vertical axis of symmetry. And we learned from last unit the shifting, right? The h shifts left and right, the k shifts up and down. Then we have our inverse parabola, and that is x is equal to a times the quantity of y minus k squared plus h. How do I know that this is the inverse parabola, Lucas? Good, because it's x equals instead of y equals. And what does the inverse parabola look like? Instead of opening up and down, it opens left or right, right? Or left, right, whatever it is. All right, so let's see that. And we know if a is greater than 0, it's going to open to the right. If a is less than 0, it will open to the left. And what about the axis of symmetry for this one? It is a horizontal axis of symmetry. So it looks something like this. Okay, so now what we're going to do, I'm actually going to tell you sort of formulas to find everything we just talked about. The vertex, which we know, the axis of symmetry, which we know, but now we're going to get into how to find the equation of the focus and the directrix and the length of the lattice rectum. And so the length of the lattice rectum, because it's perpendicular to the axis of symmetry, won't that help us decide how wide the parabola is going to be? So up until this point, we're always just like, okay, we're opening up or opening down. We're guesstimating how wide it's going to be. That lattice rectum is going to tell us how wide it should be. All right, so it's going to be a lot to memorize. Call it things to memorize. So I'll do one side blue. So for the normal parabola, where y equals a times the quantity of x minus h squared plus k, we will have our vertex, which is the point h comma k. We will have our axis of symmetry, which is going to be a vertical line. So that's going to be x equals h. So those two things we knew from last lesson. Now we're going to add in some new stuff. Our focus. And now what is a focus? Is it a line? Is it a point? What is it? It's a point. So to find the point of the focus, what we're going to do is we're going to do h comma, and then k plus 1 over 4a. Now that a is in the denominator. A lot of students want to put it like 1/4 times a. It's not. It's 1 over 4a. And then we're going to have the directrix. What is the directrix? A line. So that's going to be y equals k minus 1 over 4a. The length of the lattice rectum is going to be the absolute value of 1 over a. Why do you think it's absolute value? Yeah, you can't have a negative length. And then the last thing we do know, direction of the opening. So we know up if a is greater than 0, and down if a is less than 0. So this is everything we need to memorize for our normal parabola. Now let's talk about everything we need to memorize for our inverse parabola. So our vertex stays the same. It's going to be h comma k. Our axis of symmetry. So now the axis, since it's a sideways parabola, is our axis of symmetry a vertical line or a horizontal line? Horizontal line. So it's not x equals, it's now y equals k. The focus is going to be h plus 1 over 4a comma k. The directrix is going to be x equals h minus 1 over 4a. The length of the lattice rectum stays the same. It's going to be absolute value of 1 over a. And last but not least, the direction of the opening. We're going to open right if a is greater than 0, and left if a is less than 0. All right, let's do this. We ready? So notice what I say now. I'm no longer saying sketch. So here's some sample problems. No, the next unit is going to be all conics. So it's going to be different types of graphs, but not shooting stars or any of that. All right, so I want us to graph Should I do a normal one first and then a sideways one?
Yes.
Okay.
Yes.
Y equals 1/8 times the quantity of x minus 1 squared plus 4. Okay. So in addition to everything we just went through, the focus and the directrix and the lattice rectum and all of that stuff, guess what else I also want on this? X and Y intercepts. Yes, and the graph. X and Y intercepts in addition to everything we just went through. So let's go piece by piece. Let's start off. Let's label the vertex, or let's identify the vertex. What's nice about this one is that it's already in vertex form. So we don't need to manipulate this at all. Do you think it'll always be in vertex form? No, that's why I showed you or refreshed your memory on how to complete the square last class, right? So now the vertex here for a normal parabola is h comma k. So we are going to have 1 comma 4. Then let's talk about the axis of symmetry. I'm going to call it AOS. The axis of symmetry is going to be x equals h. So in this scenario, it's going to be x equals 1. Next, let's go through the direction of the opening. We'll do all the easy stuff first. And because A is positive, what does that mean? It's opening up. Okay, so up until this point, this is everything we've already known, right? The vertex, the axis of symmetry, the direction of the opening. Are we ready for the new stuff? Let's talk about the focus. So go back for a normal parabola to find the focus. It's going to be h comma k plus 1 over 4a. So it's going to be h comma k plus 1 over 4a. So let's work on this. Our h is 1. Our k is 4 plus 1 over 4 times, what's our a? 1/8. So now obviously we need to work on this a little bit. So now I have 1 comma and then 4 plus 1 over, can I cross simplify this? 8 goes in, or 4 goes into 8 twice. So it's 1 over a half. Well, isn't this the same as saying 1 divided by a half? Keep, change, flip. So we're going to have 1 comma 4 plus 2. So it's 1 comma 6. So we found our focus. What do you think we're going to find now? The directrix. So to find the directrix, it's going to be h, oh, sorry, not h, y, it's a horizontal line, y equals k minus 1 over 4a. Well, didn't we just figure out what 1 over 4a was? What was that? What was 1 over 4a? 2. So do I need to do that all over again? No, I just figured that out. So y is going to equal our k, which is 4 minus 2. So now our directrix line is y equals 2. To get partial credit, I need to see what equation you're using, because in case you're using the wrong equation, I can at least follow through with that. All right, so now next part is going to be the length of the lattice rectum. So I'm going to have 1 over a. So this is going to be 1 over 1/8. Isn't this keep, change, flip again? So 1 divided by 1/8 is what? 8. So what does that mean? The length of the lattice rectum is 8. So perpendicular to our axis of symmetry from one end of the parabola to the other is 8 units. What does that mean on either side of the focus if the total length is 8? 4 units on each side. So can we make a conclusion, since it's 1 divided by a? If a was not a fraction, if a was a whole number like 2 or 4 or something, Would it be a skinnier parabola or a fatter parabola? Skinnier. So what does that mean? Make it come to some kind of summarization about A and the width of the parabola. So if A is greater than 0 but less than what? If A is greater than, if we're doing the absolute value of A, let's do that. The absolute value of A. The absolute value of A is greater than 0 and less than 1. Is it going to be skinnier or wider? Wider. And if the absolute value of A is greater than 1, what does that mean? Skinnier. Exactly. All right, let's keep going. Arv, is your hand up or are you just sitting like that? Okay. So now let's talk about the last thing I want us to find is the x and y intercepts. Who remembers how do we find the x-intercept? Y equal to 0. So we're going to have 0 is equal to 1/8 times x minus 1 squared plus 4. I'm now going to subtract that 4 and multiply by 8. So I'm going to have negative 32 is equal to x minus 1 quantity squared. To undo a square, we must take the square root. What does this tell us? There's no x-intercept. How come there's no x-intercept? Because it would be imaginary. So we're going to say no x-intercept. All right, let's talk about the y-intercept. To find the y-intercept, we set x equal to 0. Um, 1/8 plus 4. So we're going to have the y-intercept. I'm actually going to leave it as a mixed number. Why do you think I'm going to leave it as a mixed number, 4 and 1/8? Yeah, because it's easier to visualize a mixed number on a graph versus an improper fraction. So I'm going to leave it just like this. So the y-intercept is 0, comma 4 and 1/8. Now we have everything we need to graph. Okay, start off with our vertex. Our vertex is 1, 4, right there. I'll put V for vertex. And then our axis of symmetry is x is equal to 1. So I'm going to draw this as a dashed line. And then we're going to have a focus of 1, 6. So we're going to do 1. I'll put an F here for focus. I'm going to have a directrix of y equals, was it 2? Y equals 2. Okay. 2. All right, we're going to have an x, no x-intercept, but we will have a y-intercept of 4 and 1/8. So I just want a little bit over 4. We're never going to be completely accurate. Okay, now it's time to figure out how wide this parabola is going to be. How am I going to figure out how wide it's going to be? We're going to go, the total lattice rectum is 8 units. So we're going to go 4 on either side of which point? The focus, exactly. Not the vertex, the focus. So here's my focus. So I have to go 1, 2, 3, 4 units to the right, and then 1, 2, 3, 4 units to the left. That is the lattice rectum length. Then what you do is you just connect these points and make our parabola, our very wide parabola. Okay, next one. I want us to graph 6x equals the quantity of y minus 3 squared plus 30. Is this normal parabola or inverse parabola? It's inverse parabola. Is this in a good format? Almost. Not really. It's not like so bad. All I have to do is what? Divide by 6. But be very careful. When you divide by 6, you need to divide it under every term. And so when I rewrite this, I'm going to write x is equal to, instead of y minus 3 squared over 6, I'm going to write this as 1/6 times the quantity of y minus 3 squared plus 5. Why do you think I wrote it as 1/6 verse over 6, Jasveet? Because that's the A term, exactly. So now this absolutely fits the format of x equals A times y minus k quantity squared plus h. Guys, can you stop, please? So now what are we doing? We're going to find our vertex. Our vertex is still h comma k. And so that's going to be 5 comma 3. Our axis of symmetry is going to be a horizontal line, y equals k. So that's going to be y equals 3. We'll talk about the opening. Are we opening left, right, up, or down? To the right, because A is positive and it's an inverse parabola. Let's go to our focus. Our focus this time is going to be h plus 1 over 4a, comma k. So now it's going to take some manipulation. Our h is 5 plus 1 over 4 times 1/6. Oh, I put comma plus, not comma, 3. So now this is going to take some manipulation. So I'm going to have 5 plus 1 over 2/3, comma 3. So now this is the same as saying 1 divided by 2/3, which is 1 times 3/2. Well, what is 3/2? 1.5. Why do you think I'm making it as a decimal instead of an improper fraction? Because isn't it easier to visualize mixed numbers and decimals versus, or plot in numbers, mixed numbers and decimals versus improper fractions? So now I'm going to have 5 plus 1.5 comma 3. So that's going to be a 6.5 comma 3. Are we all good with that so far? Okay, now let's find the equation of the directrix. The directrix is a vertical line this time. X equals h minus 1 over 4a. Well, we've already found 1 over 4a. So it's going to be 5 minus, what was it? 1.5? Yes, 1.5. So this is going to be x is equal to 3.5. What are the last two? Oh no, last 3 things I'm missing. Ready? Justin? You got it. So the length of the lattice rectum is going to be 1 over a. So this is going to be 1, or the absolute value of 1 over a, 1 over the absolute value of 1 over 1/6. Keep, change, flip. What does that become? 6 units. What does that 6 units mean? 3 on each side of which point? The focus, not the vertex, the focus. So now we have the length of the lattice rectum. Now let's find the x-intercept. So we're going to have 0 is equal, oh, sorry, nope, not 0 is equal. We're going to have x is equal to 1/6 times 0 minus 3 squared plus 5. x is equal to 9 6 plus 5. X is equal to 3 halves plus 5. 3 halves is about 1.5, or is exactly 1.5 plus 5. So x is equal to 6.5. So it's the point 6.5 comma 0. Y-intercept, plug in 0 for x. What's going to happen here once again? No y-intercept, because it's going to be an imaginary number. All right, I think we have everything we need to graph. And we need to remember, how is this going to look? Sideways. Opening right or opening left? To the right. So our vertex was the point 5, 3. Put V for vertex. We had our axis of symmetry is a horizontal line this time. Our focus is the point 6.5 comma 3. Put F for focus. Our directrix is the line x equals 3.5. We have an x-intercept of 6.5. And then it's going to be 6 units long, the lattice rectum. So we have to go from our focus 3 units up, 1, 2, 3, and 3 units down, 1, 2, 3. And so it looks like this. Yes.
What's the point that I do that electric? So I know the focus is so you can figure out how much.
So by definition, every point on the parabola is the same distance from the focus as it is to the directrix. So it's just, but it's just there for that reason only. Okay. Next part, what we're going to do is describe the width compared to the parent graph. So if I have, yes.
When we were talking about things,
Yes.
the inverse of the vertex was h comma k, but when we did this problem, the vertex was k h.
Uh-oh, did I do it wrong?
I don't, right? Because
Did I just mess up my H? H is 5, comma K3. Did I not plot that? H is 5, 3. Did I plot 5, 3? 1, 2, 3, 4. No, I did.
yeah,
You're okay?
yeah.
Okay. All right, so describe the width compared to the parent graph. So let's summarize what the conclusion we had come to by ourselves. If the absolute value of A is less, let me move this over. If the absolute value of A is greater than 0 but less than 1, it's going to be wider. If the absolute value of A is greater than 1, it's going to shrink or be skinnier. So wider or stretches, shrinks or skinnier. Okay. So with that said, let's say I have 5x equals y squared plus 4y minus 26. Is this in a good format? No, it is not. What do we have to do to make it in a good format? No, not yet. Eventually, we're going to have to divide by 5. But because the y squared plus 4y minus 26 is sort of a hot mess on its own right now, we're going to actually ignore that 5x right now. Justin? We are going to have to eventually divide by 5, but you don't want to do it yet because now you're going to add a whole bunch of fractions to complete the square with. So we actually want to complete the square first and then divide by 5. So we're not dealing with fractions. So let's go ahead and complete the square just like we did in yesterday's recording. So we're going to have y squared plus 4y. We're going to take half of 4, which is 2. 2 squared is 4, so I'm going to add 4. Since I'm adding 4 inside the parentheses, what else do I have to do? Subtract 4 outside the parentheses. So now we're going to have 5x is equal to y plus 2 quantity squared minus 30. Is this good enough? No. Now that I've completed the square on one side, now I'm going to divide by 5 under everything. So we're going to have x is equal to 1/5 times the quantity of y plus 2 squared minus 6. Is this now in a good format? So now I don't want us to graph this. I'm not even asking you to find the length of the lattice rectum. All I'm asking for us is to describe the width compared to the parent graph. Well, what is that going to be based on? Our A, right? So based on this A, because the absolute value of this A is less than 1 and greater than 0, what is that going to be? Wider. You got it. This is going to be wider. Okay, last one for today. Let's say I have y equals 3x squared plus 1. Do I need to complete the square on this? No, actually, we don't have to, guys. Isn't this the same as saying y equals 3 times x minus 0 quantity squared plus 1? So I don't need to complete the square. So now I'm not asking to graph this. I'm not even asking for the length of the lattice rectum. All I'm asking is this graph compared to its parent graph wider or skinnier? This time, because our A is greater than 1, it's going to be skinnier. And that's it. We are